This is the answer key video for page 175, Independent Practice, Chapter 3, Lesson 1. So let's zoom in on numbers 1 through 6. We have to determine whether the relationship between the two quantities shown in each table or graph is linear. If so, find the constant rate of change. If not, explain your reasoning. So to find a constant rate of change, or at least compare and look at them, we have to look at the change in y over change in x each time. So 15 to 24 is an increase of 9. 24 to 36 is an increase of 12. And 36 to 72 is an increase of 36. Okay, so far it doesn't look like they're fully linear yet, but let's take a look at the other side and then compare the change. So 5 to 8 is 3. 8 to 12 is an increase of 4. And then 12 to 24 is an increase of 12. So let's compare the ratios of the changes. So does 9 over 3 equals 3? Does 12 over 4 equal 3? And it does. Now does 36 over 12 equal 3? Yes. So it is linear. And the constant rate of change is 3. 3 cents per hour. Linear, 3 cents per hour. Okay, number 2, we're looking at to see if this has a constant rate of change. So if I'm increasing from 4.9 to 19.6, I have to find the difference. So 19.6 minus 4.9, 16 minus 9 is 7, and 8 minus 4 is 4 with 1. So it's 14.7 increase. And then from 19.6 to 44.1, let's find the difference. 44.1 minus 19.6. So 11 minus 6 is 5. 13 minus 9 is 4. And 3 minus 1 is 2. So it's 24.5. And if this is increasing by 1 each time, then the constant rate of change doesn't match. So it is not linear. Number 3, looking at not the ratio, but just the difference in change. So if the change increases by 2 up here each time, then it has to be a constant rate of change for these ones as well. So from 3/4 to 1 1/2 is an increase of 3/4. From 1 1/2 to 2 1/4, well, let's take 3/2 plus 3/4. Let's see if that's right. So this changes to 4 and this to 6. 6 plus 3 is 9 over 4. 4 goes into 9 2 times with 1 left over. Yep, this is an increase of 3/4. And 2 1/4 plus 3/4 is 3. So it's an increase of 3/4 each time. So since my change of 3/4 over my change in 2 is equal to each other each time, this is linear. And it has a constant rate of change of 3/4 vinegar for every 2 cups of oil. Okay, number 4. We're going to start looking at graphs now to determine if it has a constant rate of change. And if I increase 2 inches of water for every minute, that does have a constant rate of change of 2 inches per minute. And it is linear. Okay, looking at number 5, we have to determine if this is also linear. And I can draw a straight line through it, so it looks linear to me. And it's 2 inches for the map distance for every 15 miles on the map. So 2 inches for every 15 miles. And does 2 inches for 15, does that equal 4 over 30? Yes, it does. So this is linear. And it's 1 inch for every 7.5 miles. Okay, number 6. We have to determine if this is linear. So I see that it increases from 5 to 100. So 5 to 100 is there. And then 10 to 175. So if I have $100 for every 5 people, and then I increase by 75, so 75 over my increase of 5 people, and then this increases by 175 to 200, and each of these is worth 50, so 75 over 5 each time. Do the constant rate of change equal each other? Yes, they do. So the constant rate of change is $75 for every 5 people. So let's simplify that with 75 divided by 5. 5 goes into 7 one time, so 1 times 5 is 5. So 15. So $15 for every person is the constant rate of change. That means that it is linear as well. Okay, moving on to 7, 8, and 9. We're now determining whether exercises 1, 3, and 5 are proportional. And to determine if something is proportional, we're trying to figure out if the ratios equal each other. So does 15 over 5 equal 36 over 12? Does that equal 72 over 24? So let's determine if the ratios are equivalent. So does 15 over 5, that simplifies to 3. And 36 over 12, that simplifies to 3. And 72 over 24 is also 3. So yes, it's proportional. It's proportional because the ratios are equivalent. Exercise 3. So we're looking at this one. We're determining whether the ratios are proportional. So does 8 over 3, does that equal 2 over 3/4? Let's check that out. 2 divided by 3/4, does that equal 8 divided by 3? So 2 divided by 3/4 is actually 2 times 4 over 3, which is 8 over 3. Okay, so those are equal. And so let's see if 6 divided by 2 1/4 is equal to 4 and 1 1/2. So 6 and 2 1/4. Does that equal 4 over 1 1/2? So 2 times 4 is 5, or 2 times 4 is 8, plus 1 is 9, so 6 over 9 over 4. So 6 divided by 9 over 4. And then 4 divided by 3 over 2. So 6 divided by 9 over 4 is actually 6 times 4 over 9. And I can reduce, cross multiply, is 2 and 3. 6 and 9 both have a factor of 3, so I divided them both by 3. 2 times 4 is 8 over 3. That one's also equal. And then 6 over 1 1/2. 4 divided by 3/2 is actually 4 times 2 over 3, which is 8 over 3. So, yes, it's proportional. So let's determine if exercise 5 is proportional. So we can look at the ratios of 15 over 2. Does that equal 30 over 4? And does that equal 45 over 6? So 15 over 2 equals 30 over 4 equals 45 over 6. So if I were to simplify each of these, would I get 7 1/2? This one is equal to 7.5. 30 divided by 4. 4 goes into, does not go into 3, but 4 goes into 30 7 times. 7 times 4 is 28. Subtract, we get 2. 4 goes into 20 5 times. 5 times 4 is 20. This one is also 7 1/2. And then 45 divided by 6. 6 goes into 42 7 times exactly. So it goes into 45 7 times. 7 times 6 is 42. Subtract, we get 3. Bring down the 0. 6 goes into 30 5 times. 5 times 6 is 30. So all of the ratios are equivalent, meaning that this one is also proportional. So this is the video for the answer key for page 175. This is part 1 of the assignment.